Alright, so because of the limitations of graphing, not precise enough, can't handle 3 million. You'd probably not want to make a graph sheet of paper handling 3 million. So we have to think of some other methods, and we primarily have two other methods we work with. One is called the elimination method. Other textbooks call this the addition method. And then we also have the substitution method. Those primarily become the main ones that we use. In Math 61, we're just going to cover these just to make sure we know how to use them. Math 63, what happens is you guys go on to 3 variables. So how about x, y, and z? How does that work? And that's sort of the addition. After that, because I've taught the business math class after Math 63, it's kind of cool because then you start plugging stuff into an Excel spreadsheet. That's when you start using 20 different equations. And you're trying to figure out, okay, what's the cost analysis? What number would actually minimize cost if I have workers' comp to think about, raw distribution costs, raw material costs, all that stuff. And then that's when you have, it's called decision science for business majors, which is kind of fun class. Or then the other one is a pretty cool one. You know how in you guys have seen it in the fields, especially like the citrus fields, you see these fans, they're sitting there. Those fans are for when it's freezing, because you can only freeze citrus for so long. After that, it starts rotting. So what you have to do is you can go down to a certain temperature, but citrus trees can only be frozen, I think it was like 3 or 4 hours. Beyond that, then they're going to go bad. So what they'll do is they'll turn on the fans, and the funny thing is, when you turn on the fans when it's below freezing, it actually warms up the air. So they keep that so that the citrus trees won't rot. Now, we had a little project when I was teaching the classes, because it takes electricity to use those fans. It takes a lot of electricity if you have 20 or 40 fans. So now the question is, what is most cost effective? What's the probability of the freezing temperatures for the night? What's the cost of running the electricity? And what is most cost effective? So it's kind of fun. You're sort of doing it off of a probability aspect. Okay, is it going to happen? And if it is, when do I turn on those engines to be most cost effective? So that's sort of the same thing here. So once you deal with more than 3 variables, you got 4 different variables, 5, 6, 7, 16, 28 different variables. At that point, now you're plugging into some computer software to sort of see what's going to be the verdict there. Anyways, so now going all the way back to Math 61, the elimination method. We're going to learn how to use this. It really comes off of the property that we learned all the way in Chapter 2. If we remember, let me make a little, this little property. Remember, this is called the addition property of equation. I can add the same number to both sides, still keep it the same. Let me give you an example here where it was used, as long as this pin starts working correctly. Okay. Addition property of equality. It was like something like this. So 2x plus 6 is equal to 18. You know, what we did is we did this, right? But notice the -6, isn't -6 the same thing as -6? So we can technically put a little equal sign right here, right? And guess what we're doing? We're solving the problem. That goes away, and we're left with whatever this is. 12, is that right? So we're using this property right here. If this is the same and this is the same, if I add them up, the left and the right hand sides will still be the same. I can still keep that equal sign there. We learned it in Chapter 2. We're going to apply it to 2 different equations here in Chapter 7. Okay, there's also the multiplication property. Remember that? We can multiply or divide both sides by the same number. We're going to use that in a sort of limited amount. 1/2 of 2 is just 1, so I get an x. And 1/2 of 12 is 6, and there's my answers, right? We technically divided by 2, but remember how we talked about multiplication property? Technically, what you're really doing is you're multiplying by 1/2. Okay. Everybody set like that in their minds?
How come we just went, with the line 2 and then...
Oh, I'm just showing you that technically we are multiplying.
Okay, but you could do both ways.
Yeah, We call it multiplication property because technically you are multiplying. We don't call it division property.
Cool.
We use division as a shorthand to say, we're just going to divide by 2. but we're technically multiplying by 1/2. Okay, so these properties from chapter 2 are going to help us with this elimination method. Okay, the other little issue I had is when I was looking at these problems here, I didn't like the order of the matched problems. So this is the order we're going to take it. We're going to do number 3, then 2, then 4, 5. Then we're going to put 1 all the way over here, then 6, 7, 8, because 1 was a little different. I don't know why it was put in there. And the other thing, I changed a few problems around because the problems in the textbook, they're mostly without fractions. The matched problems had fractions everywhere. So what it is, I fudged the numbers a little bit here, so we have a more balanced approach to fractions and non-fractions. You'll sort of see that.
Do you know
as
if
we go
online has fractions or no?
I don't know, but I'll check on that. Yeah. All right, and of course the honesty question. Raise your hand if you said, Mr. H, this is the last class of chapter 7. Of course I read ahead. I read 7.2, 7.3, 7.4 because I knew this is going to be 3 sections. Another donut? Is that seriously? Okay. So let's go with it. Number 3 for starters. Just like in 7.1, we start off with 2 different equations. We're just trying to get the intersection point. That's all we're trying to do. We could graph this if we like.
Are we skipping 1 and 2? Or we're gonna go back?
We're going to do 3, then 2,
4, 5, 1, 6, 7,
then 4, 5, and then back to 1. It works out better that way. Okay. So look at this problem here. What is the elimination method? It means we're going to eliminate one of the variables. In order to eliminate one of the variables, we need to have this key little component right here. We need to have a variable and its coefficient to be exact opposites. If you have that, guess what? When you're going to add these guys up together, what's going to happen to the y values? They cancel, yeah, they eliminate. That's the whole point here. So x plus x, 2x. That does not eliminate because they're not opposites. But negative 2y plus 2y, yeah, they're gone. You can cancel them. You can put a slash through them, whatever you like, or you're just going to keep them alone. I like to put a slash just to make sure that I know which one I canceled. All right, 4 plus 6. Awesome. Divide by?
2.
Awesome. Answer is? Yes. Okay, but now look. Notice we only have the x coordinate, right? We still need a y coordinate. Right. So it really doesn't matter which one you plug into to get the y coordinate. So let me explain that because it kind of, once you see it, then it makes sense. Let's say our lines go like this. Let's say the first equation is going like this. Let's say the first line is like this. Let's say our second line goes like this. Cool. And we just learned that the crossing happens at 1, 2, 3, 4. There's my x equals 5. Good there? Does it matter which equation I use to get the y value? No, because the y value for this line is going to be right here. The y value for this line is going to be still right there, right? That's when the y values are the same. So it wouldn't matter which one you plug into. I figure plug in the one that's the easiest to plug into. Usually it's the one that doesn't have fractions in it, doesn't have a lot of minus signs in it. Cool? And we're going to sometimes plug into different equations, and that's okay, as long as we get the same y value or the x value. Cool? So I'm going to plug it into the bottom equation because that looks like the easiest to me. I don't have to deal with the negative in front of the 2. So x now I know is a 5. Then the 2, then the y, then the equal 6, and all yours to solve the rest of it out. All right, 5, 2y equals 6. Let's see, subtract 5 from both sides. Will that work? Gives us a 2y equals 1. How about divide by 2? And anybody got a 1/2 for the y value?
Yeah.
Awesome. Okay. The way we label it, because there's x's and y's in our side of problem, we're going to have to label just as a coordinate. So x comes in for the y, I'm sorry, x comes in for the as a 5, the y comes in as a 1/2. Alright, we're always going to put it like this, and of course on the test I'm going to have 1/2 comma 5. So the x has to be first, followed by the y.
And are we gonna have to graph it?
On these, you mean on the test itself sort of thing?
Mhm.
Let me think about it.
What do you mean, how do you what on the test you're gonna have it at 1/2 comma 5? Is that what you said?
Yeah, on the test, so let me answer two questions here. On the test, an option, because it's a multiple choice test, I may put 1/2 comma 5 just to
Yeah.
trick you.
Okay.
You just have to know the x has to go first, then the y. It's different. 5 1/2 is different from 1/2 5. 1/2 5 is all the way up here.
Why do you want to trick us?
Love to trick you guys, as if you have not seen so already. Okay, we good? Next one. Okay, one more little issue. What happens if you don't have opposites to start off with? That's our problem. What happens if you don't have the opposites like this one? Bummer. There's a 3x, there's a 2y for the top equation, and there's just an x minus y for the bottom equation. Well, remember that multiplication property? It allows me to multiply both sides of an equation by the same number. It still keeps it as an equal sign. It still keeps it as the same exact equation. So here's what we're going to do. We're going to create our opposites. Few easy things to do. This is what I look for. If I look for opposite signs first, see how there's a positive 2y here? There's a minus y. I have already opposite signs. So let's make exact opposite numbers. So what should I do to this guy? Yeah, I just need to multiply this by 2, and I get my minus 2y. Of course, I can't just do it for the y. I have to multiply it during the whole entire equation here. I got to multiply by 2 on this side, on the left, as well as on the right. The way I show it in the textbook, it just you do like this. You put a little arrow. But technically what you're doing, and I'll put this in here, technically what you're doing is you're doing this from chapter 2. You're multiplying this side by 2. You're multiplying this side by 2. That's what you're doing.
So we're always trying to find this, like the common thing for y up there.
You're trying to get exact opposites.
Oh,
Not so much for the y. It could be x or y. It wouldn't matter. So let me erase a few things, answer a few questions here. So if I wanted to get my x's to be opposites, what would I multiply the bottom equation by?
-3.
-3. And that would still produce me an opposite from x.
I mean, you want the same number of that variable, the opposite.
Mm-hmm.
So multiply it however to get it.
Yep. So the top equation, we're not doing anything to that. So what we normally do is we just put the little arrow. Some books keep it as nothing. There's no number here. Some put NC, and NC just means no change. You haven't changed anything, just to sort of keep track of things. I like to put NC just because then I know that's what I did. If I need to go back, I can kind of see what I did or didn't do. Okay, so the top equation, leave everything the same, no changes whatsoever. Awesome. The bottom equation, what is it? 2x. Awesome. Okay, so don't forget that all the way at the end, that -1 still multiplies that 2. That's probably the number one main mistake of Math 61 students. They forget to multiply everything by that number. Okay, now the question is, do I have opposites?
Mm-hmm.
Absolutely. Let's go for it. Let's add them up, cancel the y's, keep on going. Alright, let you guys go ahead of me to try that. I will give you an answer for x. X turns out to be 4/5. If you get 4/5, you're doing good. Then plug it in, either the top or bottom equation, whichever one you like, but I'll give you guys some time to try it yourself. Alright, finishing off this problem here, first of all, here's adding them up. 3x plus 2x makes 5x. The y's are gone, and I get 8 plus a -2. So that should be giving you a 4, and I think everybody got that. Divide by 5 gets you 4/5. Now the plug-in. Okay, so my choice, I probably go into the plug into the top because there's no negative signs to deal with. There's no fractions to deal with here. So plug it in. 3 is still there. The x, I know that to be 4/5 now. Plus 2y plus 6, no changes there except for the x being plugged in. Alright, here's my little problem right here, is that I have a 3 multiplying 4/5. I got a whole number multiplying a fraction. In that case, that changes things right there. Can I reduce anything? Nah, okay, so 3 and 5 don't reduce, so how about 12 over 5 for starters? Okay, you got a choice here. You could either subtract 12/5 on both sides, then you got 12/5 subtract x, you need common denominators, blah blah blah. That's not the way I would handle it. I would just get rid of my fraction. What should I multiply by to get rid of a fraction? 5. Let's multiply everything by 5. Then I don't have to deal with fractions until all the way at the end. Okay, 5 distributes, 5's cancel, leaves us with 12 over here. But 5 goes all the way to the 2y, leaves us with the 10y. Everybody good there? And how about a 30 all the way on that side? Alright, what should we do now? Subtract 12 is good by me, yep. So 10y is equal to 18. Divide by 10, yep, heard that already. And then, could I reduce? Perfect, yep. 9 into 5. Okay, so x goes first, then the y goes next. And
Can we
cool.
do the second problem? I chose that one.
Yeah, uh-huh. Let me do that actually here. Let me jump to this and let me do it based upon the second problem here. So x minus y equals -1. X minus y is equal to -1, so that plugs in as 4/5. Somehow I should get a 9/5, and then you tell me, what did you do? Multiply by 5, or did you subtract 4/5?
Oh, that 2x minus 2y equals -2. I put 2 times 4/5 minus 2y equals -2.
Come again, 1 second here. Let's see, what did you do? Because that's a problem.
Yeah.
And you plugged it into,
You know what?
you plugged into 2x minus 2y?
Yeah, over there.
equals-
I didn't go back to the x. I have to plug it in over there.
Real quick though, did you plug it into 2x minus 2y equals -2? Okay, you can still plug into that. You can plug into any number before you hit this little plus sign.
Yeah, I put 2x times 4/5 minus 2y equals -2.
Okay, yeah, we'll plug it into that and just see what happens here. It would be the same thing as plugging into this as well. But real quick, I want to stress, because we're going to deal with this later. Yes, you can plug in to any number right before this little plus sign, right before you eliminate one of the variables. So you can plug into this one, or this one. It wouldn't matter. You still should get the same thing. Good there? We're going to deal with something like that situation later on. So let's go to it here. So 2x minus 2y is equal to -2. So this comes in as 4/5. Cool there. Nothing reduces with the 5 and the 2, so how about an 8 over 5 here? Good there so far? Okay, what did you do then?
I totally messed up.
Okay.
9 times 5 times 2 is 10 plus 4 is 14, so I have 14 over 5.
Got it, okay.
And then I subtract the 5 and 5 from 14 and 14, and then I got -2y equals -5 over 7.
Got it, okay.
That's
So
how
let me
far I got.
then multiply by 5. That should be 8 minus 10y is equal to -10. Multiply by 5. Instead of a 14.
I probably did it really not right.
Yeah, I think that's where it went wrong, because I think there should not be a 14 anywhere here.
Yeah.
The 8 still stays, and as you subtract the 8 out, you get a -10y is equal to -18, and then you can kind of see how that's going to work out to the same problem we did, and then you get yourself the 9/5 anyways.
Yeah, 'cause I multiplied up there. See the second thing that you wrote up there? Up further up, right there? I did 5 times 2 plus 4, and then I got, yeah, 14 over 5.
Got it. Okay,
Yeah,
no,
and
there's...
then I did this, and then I got -2y. And then so everything just cross canceled, and I got left with -2y equals 5, 7.
Got it. Should not be a multiplication here
Okay.
at all. I'm sorry, should not be an addition here at all. It was just a multiplication between a whole number and a fraction. So it went a little bit beyond that. Because there's no extra x in here. I think that's the issue here, is that x gets substituted as a 4/5. So there's no extra 4/5 anywhere there, if that helps. I'll take a look at yours if you still
no,
need.
I don't get what you're saying, but I'll figure it out.
Okay, okay. Okay, so let's jump to number 4. And again, I tweaked this problem just a little bit here, just to make it a little bit easier to solve, or else the numbers did not work out. So that -2, just change it to a +2, or erase the negative sign whatsoever. Do something there. It should be 3x plus y equals a +2, not a -2. Okay, I'm going to let you guys try this yourself. Number 4, maybe. No, never mind. I'm not going to let you guys try it yourself. Maybe the next one. The reason why is because I want you guys to notice a little something extra here. What can we multiply by in order to get opposites? First of all, it has to be a negative, right? Because we're going to have to switch one of the signs over. So I have really 2 different possibilities here. I can multiply the top by a -5. That will produce negatives for my y values. We good there? Or I can multiply the bottom by a -3. We good there? See how that's going to work out? Either way, we're going to get the same answer. Okay? But in my mind, if I'm going to multiply by any kind of number, I'm going to multiply by the lowest number that I can, since I don't have big numbers. I don't want 5 times. I don't want 35 in here having to deal with 35x or something like that. So if I had a choice between a -5 or a -3, I'm going to choose a -3. Okay, I also want to show with number 4 is that notice what happens when we cancel the x out first. We still have to give our final answer as a x comma y. Okay, on top, no change, because I'm already set up for that. I will let you guys try it. So solve this. You'll solve for y first, then plug in the y and see what you get for x. So go for it. Let you guys try it first. All right, let me start it as well here. So multiplying, or keeping the top exactly the same, multiplying by -3 on the bottom. Careful, you should have a -9 over here, just to make sure you didn't multiply through everything. Adding them up, the x's are gone. Whew, the y becomes a -14y is equal to a -7. Divide through by -14, and hopefully you got y equals 1/2. All right, quick raise of hands. How many got 1/2? The other way around, how many did not get a 1/2? Okay, so let you guys catch up. We got it. Y. Okay. Okay, plugging in. Again, doesn't matter which one you plug into whatsoever. Just go for it if you like. I plugged into the top equation if you want to do the same thing I did. The top original equation. That's the one I plugged into.
How can you choose that one as opposed to the second one?
Not really an issue. The question is, why did I choose the top instead of the bottom? I don't have a multiplier by 5 that I got to deal with. I don't know. I mean, they're both the same.
Smaller one again?
It wouldn't matter too much. Yeah, there's no negatives to deal with on any one of them. They're all positive, so maybe one less step since I don't have to multiply by 5 with the 1/2. That's all. So on top, 3x plus now the 1/2 there instead of the y being equal to 2. And again, you could subtract 1/2 from both sides if you really, really wanted to. I don't. I'd like to get rid of fractions here, so how about multiply by 2 everywhere? So I don't have to deal with the fractions until all the way to the end. So distributing the 2 times 3x is 6x, 2 times a 1/2, just to go to 1, and 2 times 2 is 4. Okay, subtracting 1/2 from both sides, 6x equals 3, divide by 6, reducing that over, and that should give us a 1/2. Okay, the way we write it, even though they're both the same, right? You have to write the x has to go first still, and then the y comes down. If they were different numbers, there would be a little problem. Okay, good here. Alright, let's go with number 5. This one you may go with it by yourself. Go for it, see which one, see what you get here. We'll tell you there's no fractions here to deal with. And if you want to do it the same way I did, what I did is I canceled off the y's first. And you can kind of see why I did that right away. So I'll give you guys a minute here, try it yourself. So cancel off the y's first, and then solve for x. After that, plug the x back in, solve for the y. But give you guys a minute, try it yourself. All right, and yes, I changed that changed the 7 into a 6, because therefore it works out a little bit better. Otherwise, you get some weird fractions in here. That doesn't make sense whatsoever. All right, let's go for it here. Let's see what happens here. What I did is I multiplied by 4 on the bottom. Raise your hand if that's what you did as well. Okay. All right, so in order to have a negative 4y, you just need to multiply by 4 because the negative's already there. So then at that point, the top stays the same. The bottom is a 8x minus 4y is equal to negative 24. Boom, adding them up. The y's are opposites as planned, so 9x, cancel off the y variables. You get a negative 18, and how about a x equals negative 2? Cool. Plugging that in. Again, doesn't matter top or bottom. I chose the top just because of less minus signs to deal with. That's about it. So x becomes negative 2. And what I usually do, I like to put into a parenthesis because I know exactly what I plugged in. And then it's an extra step to drop off the parenthesis, but I know, at least I know exactly where it went from and then where it came to be. If there's a multiplication here, then I just do the multiplication. But if not, then I just drop the parentheses. Kind of keeps things in order. All right, adding 2 to both sides should give us an 8 on that side. Dividing by 4 now gives you a positive 2. So at that point, negative 2 comma positive 2. And of course, raise your hand if you got that before I did. Cool. Okay, 1, 2, 3. All but 3 people. That's cool. Okay, see a few people still trying to finish it up here, so I'll wait a little bit. All right, next one, there's an extra little piece here. Now we move back to number 1, but I want to save it for now. All right, here's our little problem. We have a fraction. That's our problem. So what we're going to do, we're going to get rid of our fraction first. So forget about the elimination method, whatever we do. We're just focusing on that little 1/2 right there that's sitting. And for the top, there's going to be no change because no fraction to deal with. On the bottom, what should we multiply by? Yeah, 2 or 2 over 1, we're just 2. 2 is fine. So this step is just to get rid of the fraction. So on top, no change whatsoever. Everything's good. On the bottom, 2 times x is 2x. Half of 2 is a 1, so therefore just a y. And 6 times 2 is 12. Okay, so that step has nothing to do with the elimination step whatsoever. That step was just to get rid of our fraction. Okay, then at this point, then the talk becomes, okay, now what should we do, or what should we multiply to get rid of any of the variables?
The top.
Perfect, okay. So you can either do a negative on the top, that's exactly what I did. Negative 1 on the top, no change for the bottom, and which variable are we trying to get rid of?
Y.
The y value. You could have multiplied by negative 2 on top, and then you would have been getting rid of the x value. So either or, I'll let you guys finish it off. And real quick here, just to say, no fractions on this one either. So you should be able to go from here to the end. All right, let's go for it here. So multiplying through by negative 1 across the top. The bottom stays exactly the same because we're just trying to get rid of the y variable. Adding them up gives you x Hey, I like that. Nothing else to do but x equals 10. Plug it back in. Okay, here's our option here. You can plug into the original top, you can plug into the original bottom, or as we stated before, you can plug into this one. You can plug into this one, again, because when you have the multiplication property, that doesn't change our solution at all, right? When you multiply by something by 2, it doesn't change anything. Alright, you can even plug into this one that we multiply by -1, or you can plug into this one. Anything that's before this little plus step. So, in my mind, the easiest one still is the original top equation. X plus y equals 2. So if 10 is the x value, that means the y value has to be a -8. And have a 10 comma -8 as our answer. So kind of careful just so you don't transpose those answers, right? It's not -8 comma 10. It's 10 comma -8. Okay. So number 6. Again, this one's the one that's going to test your abilities here. Let me start you off a little bit here. And I'll let you guys try it yourself. This is the toughest one right here. If we can solve this one, you're doing good. So let me start you off and let you guys get going. So we got fractions. What should you multiply the top equation by?
6.
By 6. You got it. We got fractions on the second equation too. What should you multiply the bottom equation by? 3. Absolutely. 6 on top, 3 on the bottom. And this is just to get rid of fractions. After you get rid of fractions, then you start thinking about what's going to happen in light of opposites. Or, by getting rid of fractions, you just might have opposites already. I'll give you that as a little hint. Cool. Alright, give you guys a minute. Try it yourself. Alright, let me give you at least a part of the answer as we go. So as you do this here, a half of 6 gives you a 3 on top, so 3x. Well, a third of 6 gives you a 2, is that right? So a -2y. And 6 times 2 is 12. So for the first equation, there's your multiplication by 6. Notice you got rid of all fractions. That's the good thing that you wanted. On the bottom, you get an x times 3 is 3x. 2/3 times 3. The 3 is going to cancel, but you're still left with a 2 on top. So you get a plus 2y equal to whatever -4 times 3 would be, which would be -12. Okay, at this point, you have the same thing for the x's and you have opposites for the y's, and that's okay, because when you add them together, you're going to get 6x. You're going to get y's being canceled and you're getting a 0, but that's okay to have 0. That's another little thing here, because do you still have a variable that you're solving for? Yeah, you're still solving for x. So what should we do to solve for x? Divide by 6. X equals, that's okay, just get 0. Okay, plug it in. Okay, here we go. Which one do you want to plug in a 0 into? Top original, bottom original?
Bottom.
Can we plug into this one?
Yeah.
Yeah, the non-fraction top or the non-fraction bottom, yeah, any one of those. And that's okay, because they're all, we call them equivalent equations. They're all the same equations. Okay, what did I do? Just checking, I plugged into the non-fraction bottom equation right here. I plugged into that one. But again, it would matter. You're just reducing your steps to solve here. So 3x plus 2y equals -12. That's the one I plugged into. X becomes 0. That's easy. That means the y has to be -6 is good. Divided by 2 gives you y equals -6. Answer is 0, -6. So that's where the intersection point happened. All right, good there. All right. Next is, we got to talk about this here. Remember on the graphs, remember how sometimes they did not cross ever because of parallel lines, right? And then sometimes the lines would be right on top of each other, right? Everybody remember the term for that? lines.
Infinite solution?
There's infinite solutions, yeah, all the numbers that are on the line, but what was the geometric term for it? Lines coincide. Okay, so let's deal with those. So these are the two unusual ones, number 7, number 8. So let's deal with this one here. And we'll read the little bottom thing on the bottom just a little bit here. Okay, but 7. First of all, what should we multiply by to get rid of variables? Awesome. We're looking at the 2x here, looking at the x over here. If there was a negative 2 right here, everything would be awesome. So let's multiply through on top by negative 2, and no change for the bottom equation. Let's see what happens here. Alright, so x times negative 2 is negative 2x. The negative 3 times negative 2 is a positive 6, so positive 6y, and 5 times negative 2 is negative 10. Awesome. Bottom equation stays the same, so 2x minus 6y equals 3. Awesome, there you go. So when you add this up, not only the x's cancel it, which is exactly what we wanted, but the y's canceled. So let me give you the proper mathematical way, and I'll give you the shortcut, which is you want the shortcut. Technically what's happening here, because you have negative 2 plus 2, don't you have technically a 0x? Yeah. Over here, 6 plus a negative 6 makes a 0y, and 0 times x is 0. 0 times y is 0, and 0 plus 0 is 0. So you can go from here, you can go directly down to this right here. So you can just say 0 is equal to negative 7.
But if you show it that way, when you put x and a y, what do you think that x is like 1x in front of it and a y? I mean, I get it, like we could just not put any of that and just do the stuff on the right.
Uh-huh.
But if you just show that, doesn't it kind of look like 1x plus 1y?
Yeah, except for the simple fact is, think about this here. Think about what numbers can I plug in for x? What numbers can I plug in for y? If I multiply them by 0 and add them together, it would give you negative 7. Is there even possible? No, right? Because if this was a 3, or negative 3, this was a negative 4, when you multiply by 0, they still just become 0. And that's the only little thing is. So yeah, normally what we do right here, we go directly down to this step right here. We just say 0 equals negative 7. Now, the question is, does actually 0 equal negative 7? No, we put a slash through this. Our variables are gone. So just like chapter 2, when our variables went away, we just put 0 with a slash through it.
No, we did this online, would it be like D&E?
Cool, yep. Online, I think it would be D and E. I think online for these ones, well, I'll check it just to make sure. Online, I think it says you have a choice. It's a multiple choice. You say one solution, no solution, or infinitely many solutions. And you have to click one of those radio buttons. And if you say one solution, then you put down the solution on the bottom. But if you say no solution, then you're good. Or if you say infinitely many solutions, then you're good. So you got to pick how many solutions first.
So this one would be a no.
This would be the no solution one. Okay, but graphically, that's the thing. Graphically, what's happening with these lines? Think back to 7.1. If there's no solution, what's happening?
The lines.
It's vertical or horizontal?
70? They don't cross, and they don't cross because of what? They're parallel. Cool. So on the answer in back of the book, sometimes what will happen, you'll just have this one right here, and then you also have lines are parallel. Alright, and this little thing on the bottom, I'm pretty sure I took this from the textbook here. It says if both variables are eliminated and the resulting statement is false, then lines are parallel and there's no solution to the system. That is from the textbook. I just don't know what page number that's on. Anybody know what page number that's on? Can you find that somewhere? Pretty sure I took it from the textbook here.
Yeah.
430? Because there's two of them. There's this one, there's another one here.
429.
429?
Where the both variables are eliminated and the resulting statement is false.
Okay, 429 for this one. And I think Stephanie was talking about this one here, right? if both variables are eliminated and the resulting statement is true, that one is on page 430, I assume. Correct?
They're right
Yes.
next to each other.
Yeah. Okay. I'll check it.
Actually, she's actually right because
Oh.
on 430 it has all four of those statements.
Oh, okay. Cool. Cool. Okay. So I'm gonna do that, and I'll put 430.
But
Cool.
on 429 it does say that as well.
Okay.
But on 430 it has both.
You're just confusing me here, so I'm gonna stop.
Sorry.
Just kidding.
Just put 430.
430. Yep. Going back here, real quick here.
Yeah.
All right, number 8. Again, same thing's gonna happen probably, and just a different scenario at the end here. So real quick here, what should we multiply by to get rid of the x?
Negative
-4
4.
on top. All right. No change on the bottom. I'll let you guys handle that one, see what happens. Cool. Alright, so on top we got a -4x, looks like a positive 8y, and looks like a -12. On the bottom I have a 4x minus 8y and a positive 12. So one thing you probably should notice right away, if anything, notice the two equations. Aren't those really just opposites of each other all the way through? If you were to multiply this top by a -1, would you get the bottom equation? Right? Negative of a -4 is a positive 4. Negative of an 8 is a -8. Negative of a -12 is a positive 12. So really these two equations are really exactly the same. Okay, so when you add them together, that goes away, that goes away. How about a 0 for that one? -12 plus 12, 0 for this one. So there's the other scenario if the variables cancel, but it is a true statement. Therefore the answer is, and that's the way the book writes it here and back, it just says lines coincide. It means one line is right on top of the other line. And of course there are infinite number of solutions. I guess we should write that in. Infinite number of solutions. All right, but we should have noticed already. It's the same exact equation, so therefore it's going to produce the same. Those two are the same exact equation. They will produce the same exact line. Okay, we're good there. That was 7.2. I think we have enough time here to do 7.3. There's just 6 problems here, and it'll kind of go quickly here as well. (7.3). We got the other method. This one's called the substitution method. So last one was the elimination method. We eliminated one of the variables. 7.3 is the substitution method. We are still trying to get rid of the variables. We're going to do it in a different way. Then we're going to go just a little faster on this as well. Okay, when is the substitution method used? It is used, you could use them all the time. You could actually just use the elimination method all the time. You could use the substitution method all the time. You just have to rework the equation somehow, and we'll see that done. But most often than not, the substitution method is used when one of the variables has already been solved for. So notice the second equation, y is equal to 3x minus 4. So that means y is the exact same thing as 3x minus 4. Those are interchangeable. We good? That's what equal sign means. So guess what? We're going to rewrite this top equation, yes, with an 8 instead of a 3, or else it doesn't work out nicely. We're going to rewrite the top equation. Once we get to the y value, we're going to substitute 3x minus 4. So let's go for it. Let's start rewriting the top equation. X plus sign. Hey, we're getting to their y value. a y value equal to 8. Let me just rewrite it here, just so it's easier to see as we plug in. You could write it like this here. So x plus sign is here. The y value now has become, and I like to put parentheses here because then it shows me again exactly what I have entered. Also, if there's a multiplier out in front, then I know I'm going to have to multiply or distribute that multiplier. So cool, there it is. The y has become 3x minus 4. That is that substitution step. That is the substitution method. Probably easier to think about than the elimination method. Alright, since there's no multiplier, the parentheses just sort of drop off, so it is just 3x minus 4. Any like terms to collect on either side?
4x.
Yeah. The x plus 3x makes a 4x. Minus 4 equals 8. Next step is?
Add the 4.
Add 4 to both sides. Perfect. How about 4x equals to 12? And x is equal to 3. I like that. Okay. Doesn't matter which one we plug into. Yeah.
No.
It doesn't matter which one you plug into, but which one's the easiest to plug into.
No.
Yeah, at the bottom, the ones that's already solved for the other variable, because there's no algebra to do, just pre-algebra. So in this case, it's y is equal to 3x minus 4 is the original equation. The 3 goes in for the x, and then just a simple pre-algebra to finish it off. How about 9 subtract 4 is 5, and then give it to me as a final answer.
3, 5.
3 comma 5 is good. There is my, so that is the substitution method right there. Okay, kind of be careful. Careful when you have to distribute something. Either a multiplier or sometimes there's a minus sign here. Just kind of be minded to distribute that little sign or the number to the rest of the number. Okay, so number 2 is all yours from beginning to end. We have a variable. It is solved for already. That's cool. So then let's substitute negative 4x minus 2 into the top equation. Give you guys a minute, try it yourself. Alright, let me start it as well here. So those are almost done. Maybe finish up. Those that are done can look up here. So top equation now becomes 2x, then we got a minus sign, and then we got the y value, which has now turned into negative 4x minus 2 equal to 11, and then yes, that little negative sign that has to be distributed to here. It's almost like a little negative 1 out here. So 2x negative of a negative 4x makes a plus 4x. Negative of a negative 2 makes a positive 2. Everybody good there? That's the only sort of big mistake we can make there. Then collecting like terms, the 2 and the 4 make a 6x. Then at that point here, let's subtract 2 from both sides. Divided by 6, and yes, we do have a fraction in our hands here. Dividing both by 2, how about a 5/3 for our x value? Alright, let's catch up here. Those that made little mistakes there, and then we're going to plug it into, of course, the second equation to be the easiest. At this point, because you have the y is already equal to negative 4 over 5/3 minus 2, this time you don't want to multiply through by 3. Good? Because you already have the y equal to. There's no point. You only do that when you need to do algebra to finish off. At this point, you're going to multiply through, again, negative 4 over 1. There's nothing that's going to cancel 4 and 3, so negative 20 over 3 minus 2. That's when you want to get common denominators. I mean, you can multiply by 3, but then now you're having to do algebra. Where here, if you get common denominators, you're still doing pre-algebra. So all yours to finish off, common denominators, and see what you guys get. Yeah, so this becomes a negative 20. The minus sign is already here. So then this becomes technically a 1. We multiply this by 3. Multiply the top by 3 gets you a 6. Good there? So this becomes a plus sign. This becomes a minus. And how about a negative 26 over 3? Cool, good job, thank you. So 5/3 comma negative 26 over 3 as our final answer. Okay, good there? All right, number 3, let's see, there's 6 problems here. So we're about halfway done here, and I think we'll make it before break. All right, next problem. What is this all showing us? Is that sometimes you don't have a variable that's ready to solve for. So we're going to do a little bit of work actually to solve that variable. So notice, real quick here, I know it says solve by the substitution method, but could you easily solve this by the elimination method?
Yeah.
Absolutely, it's actually set up. Even we have opposites for the y values, don't we?
Yeah.
Okay, but problem number 3 is just to show you, you can change one into the other. It wouldn't really matter, that's all. If I saw this in the test, I'd probably just use the elimination method to solve this one. Good there? Okay, so here's what we're going to do. We're going to pick one of these variables to solve for. It doesn't matter top it could be. If it's the top equation, I could probably solve for x. Good there? If I'm going to use the bottom equation, I could probably solve for y because I don't want any fractions. I would not want to solve this for x because when I subtract the y and I divide by 2, now I got myself some fractions to deal with. I would not want to do that. Okay, so I'm going to pick, it's either solving the top equation for x or solving the bottom equation for y. I probably don't want to even do the y on the top because then I have negatives to deal with as well. So I'm going to pick. I'm picking the top equation. And let's solve this guy for x. So what should we do to solve for x? Add y to both sides. Because we need, in order to solve, we need one variable to be solved for. Okay, so y plus 6 or 6 plus y wouldn't really matter here. So there's an extra little step. Once we got a variable solved for, awesome. Now we're ready. Let's rewrite the bottom equation. When we get to x, we're going to put in a 6 plus y. So let's try that over here. So 2. And once we get to the x, we're substituting 6 plus y. And then continue on. There's a plus sign. There's a y variable, equal sign, and 6. So yeah, elimination method, substitution method could flow into each other. Alright, let me continue this as we're getting low on time here. This time, you look at that distribution, you got to distribute that 2. So how about 12 plus 2y plus another y equals 6. All right, let's see, 2y and another y make 3y, so how about 12 plus 3y equals 6? Good there so far? Cool. Subtracting 12 from both sides. Hopefully you did that already here, but I got a 3y equals negative 6. And dividing by 3 should give you y equals negative 2. Okay, now the question is, which equation do I plug into? This one, or this new one that I made?
The new one.
The new one, of course. That would be easy enough. So 6 plus a negative 2 would make?
4.
4 is easy enough, right? Could I have also plugged into one of the original problems?
Sure.
Absolutely. It wouldn't matter here at this point because all these equations are all equivalent equations. So what I did is actually I plugged into the bottom original just to show you that it is going to work here. So 2x plus a negative 2 for the y value. Again, we mentally plugged into here. We got ourselves a positive 4. Here, drop the parentheses, adding 2 to both sides gives you an 8. Divide by 2 still gives you x equals 4. It wouldn't matter which way you do it. Don't forget though, x has to go first, then the y value first. No matter which one you found first, doesn't matter. But it's x comma y. Okay. Number 4. Number 4 is now a weird one here. You'll see it on the homework as well. So notice if I were to solve for one of the variables, if I were to solve for the y value, would I get fractions here somewhere? I'd have to add 4x to both sides. I would divide by 3, and I got myself some fractions. If I want to solve for x, I would subtract 3y, divide by negative 4, I got myself some fractions. Any which way I find myself some fractions. Divide by 2, 2 1 going to 3, fractions there. 3 1 going to 2, fractions there if I solve for y. So any which way I'm stuck. Except for the simple fact right here. Notice right there. Notice there's a 3y and then a 3y.
Just multiply the bottom by.
Okay, hold on. If we were doing the elimination step, right? If we were doing elimination, yes, I'd multiply the top by a -1, and I got myself negative 3y, and I'm good to go. But just to show you here, how would I do this by substitution? And here it is, kind of a weird little method here. Since 3y is the same thing as 3y, all I really got to do is solve one of the equations for 3y, not just a y. So let's see it. Let's see what happens here. So I'm going to take the bottom equation, 2x plus 3y equals 12, and kind of work with me, see what we get here. I'm going to subtract 2x from both sides. Notice what I'm going to get. I'm going to get 3y equal to. You could write it as 12 minus 2x. You could write it as 2x minus 12. I just wrote it as 2x minus 12. Okay, my question here is that 3y the same thing as that 3y on top?
Yes.
Ah, there it is. So notice, I don't have to solve for the full variable. I have to get a substitution. I got to get same thing in one as the same thing in the other. We're good? So here's what I'm going to do. I'm going to rewrite the top equation over here, negative 4x, plus, and when I get to my 3y, I'm going to change it into negative 2x plus 12. Cool. So I don't have to solve for the variable completely. I have to be able just to say this is the same thing as this. Okay, I see a few of you staring at the board like you just saw a ghost. So.
I know you said you plugged it into the first equation.
Mm-hmm. So let me rewrite this here. So the top equation is negative 4x plus 3y equals negative 6. So that 3y and that 3y and this 3y are the same. So therefore, if 3y is the exact same thing as negative 2x plus 12. So I substitute that in.
That's longer though, huh? As opposed to doing a -1.
Yeah, in this method, substitution step is longer process than the elimination method. Substitution step, when is it used? When one of the variables has already been solved for. That's when. That's when you want to use it. And again, the book is just showing you all the different sorts of ways to see it. All right, let's go for it here. There's a plus sign here. That means I could just drop the parentheses. I'm going to erase this here so it doesn't get in our way. Erase this. Okay, and go. Drop the parentheses completely, so minus 2x plus 12. Collecting like terms, so negative 4 to negative 6. I'm sorry, I gave you the answer. Negative 4 to negative 2 added together gives you negative 6. Subtracting 12 from both sides gives you a negative 18. Dividing through by negative 6, and we should get ourselves x equals 3. Alright, and it's just whichever one you want to plug into. The original top, the original bottom, or can we even plug into this one right here?
Yeah.
Yeah, remember we just changed the order of them around, but it's still the same exact equation. So even if here we could actually even do this. So whatever one you want. Top original, bottom original, or this. Okay, top. Karina did the top original, that's fine. Just to show you a different flavor. I'm gonna plug it into this one here just to see if we get the same answer. So 3y equals negative 2, and the x becomes a 3, and that becomes a negative 6. Negative 6 plus 12 gets you a positive 6, divided by 3, and gets you y equals 2. Okay, Karina, plug it into the original top. Did you get y equals 2 as well? Not good.
I got -2.
-2. Okay, I can plug into, let's see. Did you plug into the top or the bottom?
The bottom one, that one.
The bottom, okay. So this guy here should have been 3 times 2 is 6.
Oh.
Subtract 6 from both sides gives you a positive 6 here. You should get 3y equals 6. Good there? Okay. Any other questions on this before we get a final answer here? 3, 2? Two more problems to go. We're done. Oh, I think I fried some of your brains here already here. Okay, number 5, number 6, let's go for it. So this one, looking at this one, definitely I would do substitution step right here. Right, the y variables solved for. Let's substitute, let's see what we get. And of course, this was going to be a weird one.
Would you put like 1 for the x, or would the x just be canceled?
X would be canceled, it would be a 0x. So let's see what happened here. Yep. So rewriting the top equation, it's a 3x plus, and then the y changes into a negative 3x plus 5 equal to 5. Everybody good with that step, the substitution step? After that, we get to drop the parentheses completely here. So you got a 3x minus 3x plus 5 equals 5. And then you got cancellation on yourself, right? Because you got 3x and negative 3x. 3 minus 3 is a 0, so technically those are gone. And you got this. And it's really all about a true statement or a false statement. If you get yourself a true statement, you have one answer. If it's a false statement, it's another. Let's go backwards here. Go back to the previous section if you need to here. If you have a false statement, the answer is no solution. Awesome. If you have a true statement, the answer is lines coincide, and you have infinite number of solutions. That's what you get with that question.
Why didn't you subtract the 5 from the 5?
Ah, good. Sometimes you guys, students do this. They will subtract 5 from both sides. You get 0 is equal to 0. And that's still okay. At this point, I would stop because there's no variable to solve for. So that way you just stop. There's no point to go further. Yeah, if you subtracted 5, you still get a true statement, which is 0 is equal to 0. You just don't need to go any further there. Okay. And okay, one final problem here, except we got to look at example number 6 first, real quickly here. We're talking about phone plans and being charged for phone plans. So now this really dates the textbook, because I don't think, unless you're calling internationally, right? At this point, they get charged per minute. But the following table shows 2 contract rates charged by GTE Wireless cell phone usage. It says you got plan A, and then it tells you what the y variable. The y variable is the monthly charge. X is the number of minutes, so you do have to define those. But they're sort of defined in the problem itself. So it says the charge for plan A is you get a flat rate of $15. No matter how much you use, you're going to get $15 charge. And then you're charged $1.50 per minute. So that's why you have the little X as a multiplier. The second charge, or the second plan, is Y equals flat rate of $24.95. That's given right away. And then it's 75 cents per minute of usage. Hey, real quick here. Do I have one variable that's already solved for? Yeah, in fact, actually, I have 2 variables that are solved for, right? One for each of them. So here's what we do here. We take this one right here. It doesn't matter which one you go. You're going to take this one, and you're going to plug it into that right there. Good there? Do you see how this equation comes about right here? So the y, the second y, changes into the first equation of 1.5x plus 15. And then you start doing a little bit of work here. In this case, they subtracted 0.75x to both sides.
So it's kind of
Subtracted
like
15.
The ones of the boat, sort of.
Set them equal to each other, sort of thing, because they are equal. Yeah. In the same amount of time. Yeah. All right, let's do our problem then here. So repeat example 6. If plan 1 charges a flat rate of $25 and it costs $1.20 per minute, can you give me that plan? I'll start off. Y equals. So a $25 charge per month and then $1.20 per minute. What would that look like as a equation? I go with that, yeah, 1.2x or 1.20x, whatever you like, plus the $25 as a charge. The second plan charges $40 a month at 90 cents per minute. Perfect with that, yeah, 0.90x or 0.9x plus the $40 a month. All right, so now the question is, at how many minutes will the two rates cost the same amount? All right, so we're going to take that 1.20x plus 25 is equal to the 0.9x plus 40. So technically that's what we did right here with the blue circles here. We took the top equation, made it into the bottom y. Okay, just to finish up here, I know we're behind schedule a little bit here. We're going to subtract 90 cents from $1.20. And we can put 30 cents or 0.3x. Subtract 25 from 40 makes 15. And then this little step I want to do with you guys here. So 0.03 divided that and 0.3. So I divided both sides. And how many times does 0.3 go into 15? I don't think so. But let's do this here. Whenever we divide fractions, we can't have decimals in it. We want to get both whole numbers before we divide. So what we do is we move this over once. If we're moving over 1 on that one, we got to move over 1 on top as well. So this really becomes, anybody?
150.
Yep, 150 over 3. Now, how many times does 3 go into 150? Yep, 50 times. That's going to be 15, nothing left over. 50. So real quick here, can you give me an English sentence that makes sense of the problem, of the number, which is 50, and the units that go with it? Give me an English sentence that includes all that in there. And I'll give you the question here. At how many minutes will the two rates cost the same amount? Not 50 cents per minute? No. Yeah, that's why it's so crucial to put the units in there to really see what you're saying. So it's not about total cost, because the X did not stand for total cost. The Y stood for total cost.
So 50 minutes.
It's 50 minutes. Because the minutes are the ones that are counted, right? Because the X right here stood for minutes. The Y stands for total cost. So the rates will be the same in exactly 50 minutes, or in 15 minutes of usage, maybe, something like that. So if you were to use 50 minutes of talk time, the rates will be the same. Notice we haven't solved for Y though. We don't know what the charge would be if we used 50 minutes, right? But would it matter which one we plug in the 50 to get the total charge?
No.
No, because we would get the same one on both of them, right? Whatever that would be. Let me just do it maybe look really quickly in my mind here. If I plug in 50 into here, 50 times 0.9 is 45, and 45 plus 40, that would be 95. So the charge, if we want to solve for Y, the charge would be $95. I don't need to plug into the top because I assume it's going to be exactly the same for the top as well. Okay, good there? That's a little bit of a tough one there. Alright, that is the end of 7.3 with like a sort of like a little word problem as we finished off with this here.